In question 1 of this exercise, we have to find out which congruence criterion we can use in each of the following parts. So let's look at the first part that follows this question. So in the first part, we have these two triangles ABC and DEF, in which AC is equal to DF. So let me mark this. AC is equal to DF. Then AB is equal to DE. So AB is equal to DE. And then BC is equal to EF. So BC is equal to EF. And so triangle ABC is congruent to triangle DEF. And we have to specify which congruence criterion has been used to make this claim of congruence. Well, we can see that the three sides of triangle ABC are equal to the three corresponding sides of triangle DEF. And therefore, in this part, the SSS congruence criterion has been used. Okay, because the three sides of three corresponding sides of the two triangles are equal. So that's part A. Then in part B, we have these two triangles RPQ or PQR and XYZ, which have been claimed as congruent. And okay, so here's the congruence relation, PQR congruent to XYZ. Now let's look at what is given. So ZX is equal to RP. So ZX is equal to RP. Then RQ is equal to ZY. So RQ is equal to ZY. And then angle PRQ is equal to angle XZY. So angle PRQ here is equal to angle XZY. So what congruence criterion do you think has been applied here? Well, two sides and the included angle of the first triangle are equal to the corresponding two sides and the included angle of the second triangle. So for this part, we have, or the problem has used the SAS congruence criterion to make this claim of congruence. Okay, so for part A, the answer is SSS, and for part B, the answer is SAS. Now let's go to part C, in which we have these two triangles LMN and GFH. So these are the two triangles that have been claimed as congruent triangles, and we are given that angle MLN is equal to angle FGH. Angle MLN is this angle FGH is this angle here. Then we are also given that angle NML is equal to angle GFH. Angle NML is this angle GFH is this angle here, GFH, and then we have ML is equal to FG. So ML is this side and FG is this side. So what we see for these two triangles is that two angles and a side pair of the first triangle are equal to the corresponding two angles and the side of the second triangle. Okay, so two angles and a side in the first triangle are equal to the corresponding two angles and the side in the second triangle, and this means that the ASA congruence criterion can be applied to make this claim of congruence for the two triangles in part C. Okay, and then we come to part D. In part D, we have the part claims that triangle ABE is congruent to triangle CDB, and we are given that EB is equal to DB. So EB is equal to DB. Then AE is equal to BC. So AE is equal to BC, and angle A is equal to angle C is equal to 90 degrees. So angle A is here 90 degrees, angle C is 90 degrees here. So we see that in these two triangles, both of them are right angle triangles, and the hypotenuse and one side of triangle ABE is equal to the corresponding hypotenuse and side of the second triangle, and this means that the RHS congruence criterion can be applied to make this claim of congruence between the two triangles. So that completes question number 1.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.